Okay, 46. Okay, so red light has a wavelength of 590 times 10 to the negative ninth. Find the frequency and the energy of the wave. So there's two equations here to worry about. One is the energy and one is the frequency. So this is the frequency wavelength velocity equation. It basically shows how the speed of the wave is related to the frequency and the wavelength. And this is the energy equation. It shows how the energy is related to the frequency. So it wants to know how much frequency and energy there is. So I'm going to start with frequency. So V equals F lambda. So we need to know what the velocity is. Well, we're talking about red light, so the velocity is this, 3 times 10 to the 8th. Equals the frequency times the wavelength. The wavelength is 590 times 10 to the negative ninth. So to get F by itself, you divide that to both sides. So 3 times 10 to the 8th divided by 590 times 10 to the negative ninth gives me 5.08 times 10 to the 14th. Yes. Well, this first number will be. The second number will not be as bad. If you're having trouble putting that in your calculator, if you want to do it, there's a exponential or there's like a scientific notation button on your calculator. You can use that. That's what I do. But if you're having trouble with that, just put everything in parentheses. So 3 times 10 power 8 in parentheses divided by start parentheses 590 times 10 power 9 negative in parentheses equals, and there's your number. So as long as you put everything in parentheses, you can just put it in the way it looks to. So that takes care of the frequency. Then we need to know the energy that the wave has also. So that equation is E equals HF. All you have to do is multiply H and F together. H is a given. 4.14 times 10 to the negative 15th electron volts. That's the unit we're going to use is electron volts. So 4.14 times 10 to the negative 15th times what we just got for F, 5.08 times 10 to the 14th. And I got 2.1. And these are electron volts. The reason they're so small is because the wavelengths are really small. So because the wavelengths are really small, the energy value is really small. Okay?